Okay, I'm back. So the next thing I was going to discuss a little bit is some of the software that's available for SDRs in general. But all of this software specifically pertains to I&Q processing from a Softrock or our transceiver. Although HD-SDR has wonderful capabilities for getting signals from lots of different places. Let's see. There's my HD-SDR. Okay. This basically has the top section is a huge spectrum display in waterfall of the entire spectrum that the radio is processing. Now, the width of the spectrum that's being processed is determined by the sample rate of your sound card. So if you have a 96 kilosample sound card, you'll see 96 kilohertz of spectrum. If you have a 192 kilohertz sound card, you'll see 192 kilohertz of spectrum. We're looking at 40 meters here in the center. We're tuned to a lower sideband signal, and you can tell sort of from the waterfall display above it that it's a couple stations in varying signal strength. They were rag chewing as I was making this screenshot. And over to the right, that looks like a broadcast. It's certainly an AM signal. You see a strong carrier and sidebands on either side, so that's probably a broadcast. And at the extreme left here, that's a sort of a big pile of signals. Maybe that's a DX pileup or something going on. But what's nice about this is that when you show this to someone who's never seen a ham radio before, it's very intuitive about what's going on here and where the signals are and who's listening. And when I take it and show it to middle schoolers and high schoolers, they almost immediately pick this up as if it was something on their cell phone. It gets a lot more interest than when I go out with a radio. The lower section of the screen shows the decoded spectrum of the signal in question. And they've implemented their filtering a little bit. It takes a little bit of getting used to. What you do is you drag these red lines in or out to adjust the bandwidth of that you're decoding. And it also changes the width of the light blue section in the center. Now, to change the frequency, you've got the frequency window down in the lower left, but you can also click on the spectrum, and it will tune to any of the signals that you see, and you can drag the slide rule between the waterfall and the spectrum. And another nice thing about HD-SDR is that you can collapse any of these windows. You can collapse it all the way down to just a little control panel, which means it also turns off the processing behind that window. So you can use it as a low bandwidth remote control capabilities. You can, with this piece of software running on your PC and an Ethernet connection, you can operate your radio from anywhere with just a remote desktop type function. The second piece of software I'm going to talk about is Power SDR. This was developed by Flex Radio primarily for use in the products that they sold, but they made an open source version of it for experimenters. They've sort of abandoned Power SDR for their new software suite that runs with their new radios. And what's nice about this one is it's much more intuitive to someone who's used to radios. The controls are laid out more along a traditional sort of radio layout with band select buttons, mode select, filter select, shift and width knobs, CW keyer, just all the sorts of things that you would normally expect to see with a radio. Both of those are Windows-based software. If you use Linux, there's lots and lots of SDR software. I've just picked probably one of the more prolific ones, which is Quisk. And again, it has a large spectrum display in the center, and you can click on anything you see in the spectrum to tune it. And then it's got fairly intuitive buttons as to what they do down here at the bottom. And what's really nice about this is you don't have to run it on a PC based or a laptop. You can run it on a Raspberry Pi with a 7-inch touchscreen, put it in a box with a Softrock or an RS-HFIQ, and you've got a self-contained radio with a touchscreen interface ready to go for, well, in the case of the Softrock, it's very inexpensive. And not to leave Apple behind, there are some software SDR programs written to run on the Apple operating system. I'm not particularly familiar with them. I did a little research to find some of them. And then as I realized as I'm looking at this screen that if I were forced to use this, I would hardly know where to begin or what to do. But maybe I'll reach out and see if I can make it work with our radio at some point. There seems to be a lot going on with this SDR-DX software. Now I'm going to go back to the Softrock. If you're not familiar with it, it was a kit designed by Tony Parks based on the Talo detector. He started in 2005 and has shipped over 15,000 of these things. It's got a 1 watt output, and one of the drawbacks is a single one doesn't cover the entire HF band. He's got 4 versions that cover 160 meters, 80 and 40, 20, 30, 17, 15, 12, and 10. And there's been a lot of attempts to make these things cover the entire band. But it's not been an easy nut to crack because you really need a bank of filters to do it. But what's amazing is it's an $89 radio. And for $89, you get a multi-band, multi-mode, high-performance digital radio running the SDR software. It's not like you've got something with in a tuna fish can with a straight key and a crystal sticking out the top. No, this is a serious high-performance radio for $89. But what's even more amazing, if you pay $124, Tony Parks himself will build it for you. I find that really amazing. I want to do it just so I can have one. When we took a look at it, we designed the RS-HFIQ. Now, RS stands for Radio Shield, which means that it's based on the Arduino technology. With your Arduino class coming up, I thought that might be interesting. That up in the upper left of that board is an Arduino Nano that we use for control. This radio has a 5 watt power amplifier. It covers every ham band from 80 to 10 meters. We developed it through a Kickstarter campaign, and we raised enough money to build 500 kits, of which 300 have been shipped. The cost for the board, as you see it there, is $239 assembled and tested. We also added a 2.5 part per million TCXO, so when you run the FT8 and whisper modes, it's dead on frequency. We put a low noise amplifier before the mixer, so it's got better noise figure than the Softrock. And using the Arduino Nano means that we've got open source firmware with an IDE that anybody can download. So it's easy to upgrade the firmware, make changes. If you don't like our interface, it's a piece of cake to write your own. The Arduino has wonderful libraries. So when I actually wrote the software for this, it's only about 15 or 20 lines of code with the libraries for the various functions that it does. Here's the block diagram for the radio. On the left, you can see the Arduino Nano and parallel lines. There's band select lines that go over to the RF section that control which band it's on and do the transmit-receive switching. And I used opto isolators on there so that there's no electrical connection between the Nano and the RF section. And what this does is it eliminates the possibility of digital noise, switching noise, ground loops from the PC getting into the RF section. Our frequency generator is the SI5351 from Silicon Labs, and it takes a 25 megahertz clock. It's a little teeny tiny chip, and you can program it to make any signal from 4 kilohertz to 225 megahertz And the library we're using in the Nano gives you control to 0.01 hertz steps. Now, my control function only uses 1 hertz steps because it was getting a bit ridiculous, but it's really an amazing chip. It has 3 outputs, so we're using 1 to drive the local oscillator at 4 times the frequency. We're using 1 as a built-in test signal. It's loosely coupled back into the receiver, so you can turn it on and it makes about a minus 50 dBm signal that you can use to ensure that your receiver's working and everything's balanced. And then one of them can be connected to a jack on the back of the radio that you can use as a signal generator, or you can use it to drive converters to get to 6 and 2 meters or 160 or some of the new low bands. So there's a lot of flexibility there with that clock generator. Now on the right-hand side of the drawing, all the switches are shown in receive. So I'll start there. The signal from the antenna gets routed to the bank of bandpass filters. There's 5 of them, and they're switched in with pin diodes. Out of that, it goes into the LNA, which also doubles as a driver in transmit. And then it goes into what I call a frequency selective attenuator, which has more loss at the low frequencies and less loss at higher frequencies. So the overall front end of this radio has about 0 dB gain at 80 meters and about 12 dB gain at 10 meters. So when you're operating in an environment with lots of very large signals, it doesn't tend to overload the mixer. But when you're operating at the other end, at the higher frequencies, where weak signals and noise figure are more important, it has more gain. And it's worked out pretty well. And that's magnetically coupled into the quadrature down converter. So again, there's no electrical connection between where the I and Q outputs connect to the PC and the control system or the RF. It's all isolated to eliminate ground loops and switching noises. When we switch it all to transmit, we take the I and Q signals from our sound card, we convert them up to RF, we run it through the bank of filters, then we have our driver, our 5-watt power amp, and then we go through a bank of low-pass filters to make it legal to operate on the air. So let's say you wanted to get one and you wanted to set up a station. Now, if you buy a Yaesu, Kenwood, ICOM, Elecraft radio, you sort of take it out of the box, plug in the power supply, the antenna, the microphone, and you go charging on into the HF spectrum. With our radio, you buy it, you hook up the power supply, you hook up the antenna, and you go nowhere. You've got to get the sound card out. And the sound card is for digitizing the I and Q that comes out of the radio and creating the I and Q that goes into the radio on transmit. So you have to hook them up with a pair of 3.5 millimeter audio cables. That's 1/8 inch for the old guys. And then you're still not going anywhere. You got to break out your computer. And we're gonna have to hook up both the radio and the sound card to the computer with USB. Now, of course, the sound card has the data stream that carries the RF data that the computer is going to decode. And the second USB goes to the radio to tell it what frequency to be on and then tell it when to switch from transmit to receive. Now, at this point, you can actually probably do some operating as long as it doesn't involve talking to anybody. This would be good for digital modes. You could use PSK31, FT8, Whisper, with software just running on the computer. But if you want to actually have a QSO, you need a microphone on the computer, and I'm not actually sure you can hook a D104 up to a computer, and then some speakers or headphones. Now, it might be possible to use the speaker and microphone that are in the laptop, but I think you'll find that if you attempt that, you'll very soon want to have some sort of microphone and audio that's dedicated to ham radio. So that's where we get sort of 2 sound devices that are needed to do this. One for the audio in and out of the computer, and one for to drive the radio. And then let's look at the software it's going to take to get it going. For our RS-HFIQ, we have what we call the supported configuration. If anything that I've talked about tonight, you could see that a software-defined radio comes with different options. There's lots of different software that runs and lots of different things to do, and we can't really offer support on all of them. So what we've done is we've come up with a standard configuration, which is the RS-HFIQ transceiver, that StarTech USB Soundcard, HDSDR software, a rig control package called OmniRig, which is also free to download, and then we have our own little RS-HFIQ control panel. And if this is the configuration you use, we absolutely fully support it. We guarantee that you can get this up and on the air, up to doing a Skype screen share with me so I can see what you're doing and get the thing up and running. And out of 300 radios that we've shipped, I've only had to do that about 5 times to get the software up. But in every single case, we've been able to do it. Of course, we talked about HDSDR. OmniRig it sits in between HDSDR and the hardware, and it tells it what COM ports it's on and how fast to talk to it. It's pretty easy to set up. And then the RS-HFIQ control panel controls the functions that HDSDR doesn't know anything about. I mentioned the built-in test oscillator. You would use this to set it to a frequency, turn it on and off. The external oscillator, it also gives you a chance to turn that on and off. And then we've got a way to enter a fixed offset so that if the oscillator's a few hertz off, you can adjust for that. And of course, if 5 watts isn't enough, we have that kit I mentioned earlier, which is 2 to 3 watts in, 50 watts out. It covers 160 to 6 meters. It is FCC certified so that we're legal to sell it in the United States. It does automatic band switching with our transceiver, the KX2, KX3, 817, Flex 1500, and the ELAD. And it's got a QSK option available to get rid of the TR relay and use diode switching for folks who like CW. And there's a wide range ATU option that you can put inside it. And this comes as a kit, so you're going to be putting stuff together. But all the SMT stuff's already soldered on. It's all through hole and mechanical assembly. And it's a nice addition if you want a little bit more power or to even drive a bigger amplifier. And so where's this going? In the works, we'd like to have standalone operation. We'd like to get rid of the sound card and all the cables and the USB and the laptop. And we were approached by Dave Miller, who runs up in Canada, who runs something called the STM32 SDR project. And it's basically everything after INQ. It was made to use with a Softrock or other INQ transceiver. And it's a standalone processor with a touchscreen color display that sits in a little box with a tuning knob and an options knob and does all of the functions. And what he did was he made us a special version that mates exactly with our radio. You actually pull the nano off it, and it mates with our board and slides into a little case and makes it a completely standalone radio. So if you don't like the idea of having to have a computer operate it, we're going to have an option for that soon. Hopefully we'll have those ready to sell at Dayton. It depends on if I can get it all up and running by then. The other thing we're working on is a 25-watt auto tuner, which again, if you see the picture, it was supposed to have an Arduino Nano, but I kind of ran out of horsepower on the Nano, and I had to swap to a Nano compatible board. Well, an Arduino compatible board. If you can see all those little white wires, it isn't exactly Nano compatible. But it has twice the memory and 4 times the speed. But I'm running a 7 inductor, 7 capacitor antenna tuner with the tuning algorithm, and it runs that little OLED display and makes meter displays and stuff. And it'll have dual antenna support where it'll store different tuning solution for different antennas, and it'll also store which antenna you use on which band. So if you have like a tri-bander and a 80-40 dipole, it'll know that you want which antenna you want selected on either band. So once you get it set up, you'll never have to mess with antennas again. And that's pretty much all I got for this evening. If I had to make some conclusions, I would say that software-defined radio technology in all of its little incarnations and flavors is certainly taking over HF ham radio equipment, and that's a good thing. In general, we've got much more high-performance equipment than we had 20, 30 years ago. And thanks for your attention, and I'll be happy to field any questions.
Would this present?
Wait, we get a mic.
I'm sorry.
Would this presentation be available to be watched on the web for folks that are not here this evening?
I can certainly make the file available. It may be beyond my web programming to actually put it on one of our websites, but if someone there wants to make it available, that's fine.
Okay, fine, thank you.
I'm recording it.
Do you know if anybody has attempted to convert a what you call it? Signal link USB to doing the IQ?
Most of the ones that are dedicated for ham radio aren't two-channel. From what I've seen, they're generally made to add digital mode communications to an analog radio. That's what they're designed for, and they do that very well. But they generally don't support stereo operation because you wouldn't normally need that for that function. So I haven't seen either the Signal Link or the Rig Blaster as being a viable option. And again, if you have to go out and buy it, that StarTech that I show there is $30. And if you want a really, really high performance one, it's going to be $70. And the dedicated ham radio ones are considerably more expensive than that.
Okay. Just thinking that, there's the processor right in there, and there's the sound card right in there. Maybe just a couple of cuts and jumpers could modify one to have a second input. Anyhow, thanks.
Mm-hmm.
Just one second, Scott. Are you going to put this on the website? If I have permission to do so, yes.
Yeah, well, certainly. There's no proprietary information or anything on it. It's all available.
So it'll be on the club website. Okay.
Sure. Thank you.
So back to the, this is Mike, by the way, back to the block diagram where the I and the Q signals came out of the mixers with the local oscillator. Those are the analog, yes, the low pass filters, those are analog signals that go into the sound card. But there's also a digital version of the I and a digital version of the Q?
Well, that's what the sound card is for. That's what the digitizer or the StarTech in this picture it does. It takes those two signals and applies it to the left and the right audio signals, and that's where the digitizing happens.
Okay, I see in the picture now that one other analog connector is, one's a microphone, the other's a headphone, so that's not used in this implementation.
Well, yeah, we're only looking at the receiver. The transmitter looks almost exactly the same and would hook up to that headphone jack. And what's really cool about the little StarTech there is that knob that's on it controls your transmitter power.
Wow, okay, thank you.
Hi, this is Tim. So halfway through, we started talking about Softrock, and I'd been wanting to get one for a long time. So I used my cell phone. I've just placed an order, so I'll be able to update the club in a while as to whether I've managed to get it working.
Yes, there's a lot of tiny components. I didn't show you the backside of the board with all the little surface mount ICs and stuff, and toroids to wind. But they've got excellent forum support folks to help you out if you have trouble getting it working. But they're a lot of fun.
You want to cancel your order?
Then get the rest of the story.
On your website, you show a case that goes with the board. Is that part of the package?
I think it's $70 extra. The idea was that the board would be useful. Well, the board alone would be useful for folks who wanted to integrate it with Raspberry Pi or something like that. So you don't have to buy it with that case. With the case, I think it's $179 with the case. So it must be a $40 case. Yeah. And again, you might want to get a different case because we'll have a different case if you want to hook it up with the STM32 processor and make it a standalone radio. It's the same size in X and Y. It gets a little thicker in Z.
This is Dave. Is there any chance of adding 160 and 6 meters to that rig?
The reason we didn't is the pin diodes. Pin diodes are getting very difficult to find that go that low in frequency. Everybody seems to want to talk on cell phones now. And the size of the case. But like I say, we have an LO output, and I know that people have built converters to convert everything up to 2 megahertz, kind of 5 megahertz higher, so it comes out in the 40 meter band, and you can program it so that it does at least receive on 160 and the other two new low band ham bands. And we may eventually put together a 2 and 6 meter converter for it, because again, like the local oscillators there, all we need is a mixer.
On your slide with talking about image cancellation, was that being done in the digital realm or is that analog?
Okay, let's go back. Some of it's being done in the digital or in the analog. The first mixing where you get the two, the I and the Q signal. Everything in the block diagram on the bottom of this slide is analog. It's actually implemented using digital switches, but these are all analog signals, except this last 90-degree phase shift. This last 90-degree phase shift happens in the digital signal processing, because that's actually the very difficult one to do. It's difficult to maintain a perfect 90-degree phase shift over 200 kilohertz of spectrum in analog, but it's pretty easy to do it in digital.
Well, in a wideband digital receiver, wouldn't your original sampling be done before you're mixing?
Well, right. In a direct or a direct sampled one, it certainly would be, but not in an IQ. This IQ is sort of a zero IF, where you convert the spectrum that you're interested in down to zero, and then you use low frequency samplers to come up with a digital stream. That's how virtually every cell phone works. They use this. They don't have IFs or anything, and the frequencies are too high for direct sampling. What this allows us to take advantage of is the really inexpensive, really high performance A to D converters that we call Soundcards. The StarTech Soundcard has a 96 dB of dynamic range. The Asus Sonar and the Creative Labs X5s can have up to 114 dB of dynamic range. So that and they're just $100 devices. So the reason for using this sort of topology of bringing the signal down to where it can be handled by audio processors is to take advantage of that little niche in technology that makes really high performance radios at a really low cost.
Thanks.
Jim, this is Forrest. When we emailed, I think it was in November, you had mentioned that somebody was working on getting QUISC on the Pi 3 for your radio. Do you know if that's been accomplished yet?
I haven't had any reports. I have made some arrangements to send one of the radios down to the guy who does the Pi SDR, which is an interesting project. It takes an INQ radio and makes it a power SDR client, and we'll be doing that. QUISC can't be too far away. I might do it myself if I get a spare weekend, because the radio controls nothing, and there's lots of INQ based stuff that runs on the Pi. So we just have to figure it out.
Okay, thank you.
This is kind of off subject of that, but I was wondering, what do you think of the technical comments about these real cheap, the RTL-SDR real tech USB that seem to have started a lot of this receiver stuff?
The RTL dongle is perfect for what it's designed to do, and that is add digital terrestrial broadcast television to your PC. It has some pretty serious limitations. It's designed so that it's only working on one signal, and that signal's coming in at a high signal to noise ratio without any interfering signals. And that's why they can make that thing useful with 12 bits. 12 bits is about a 60 dB dynamic range. So if you take their 20 megahertz of spectrum that normally is a single signal TV signal, and you put the 40 meter band into it, with a dynamic range with thunder crashes of something near 140 dB, it just is not going to work very well. It looks like it's working, and if you use it on the bench and you don't put in too loud or too soft signals, it runs with all the software. But I can't even imagine what it would look like on a afternoon when the band is really active on 40 or 20 meters.
All right, it looks like we're out of questions. There was your hand going up. Thanks, Jim, for your time. We really appreciate it. That was very good.
Thank you.
All right, good night, everyone. Thanks for coming.